So now I'm going to introduce a new kind of collection in C#, and that's called a list. Now a list is quite powerful. Internally, it's actually built upon a standard array, but it includes a lot more options and a lot of ways you can actually work with the information inside of the array, for example. Let's talk about this example right here. We're defining an integer array in C#, and we're just giving it some random number values. We're using a for each loop to go through each item in the collection and outputting it to the screen. So if I run the application now, you can see all those numbers right there. So very simple. What I'm going to do is create a new list, and I'm going to kind of mimic this functionality so you can see the difference between an array and a list, for example. Now, lists, it's a bit of a complicated subject given our learning so far, so I'm not going to explain everything, but I will cover some of the things to do with lists now. So how do we create a list? Well, the data type is list. Now, there's a new notation we haven't really talked about, and this is called generics. Now, I'm not going to talk about too much about generics because I think it's quite a complicated subject at the moment. But what I want to do is define a list which contains integers, for example. So you can see Visual Studio is trying to help me out here. It's actually hinting what I want to do, and it's correct. So let's just press tab on the keyboard there, and it's written this notation out for us. I'm just going to complete this. So we've mimicked the functionality above. Now this line right here is exactly the same as this line right here. This is a type of collection. This is a type of collection. It's an integer array here. It's an integer list, and they'll contain the same information. And I'll prove that to you. So if I loop through this list right here and output all the numbers to the screen, it does exactly the same thing. So how do we sort of define and initialize a list in C#? Well, we use the list keyword with a capital L, and in these kind of angular brackets right here, we put the data type that we want to store in the list. Similarly, if we wanted a list of strings, we would do that, for example. So we put the data type in these angular brackets, give it a name, and then we use an equals sign, and then we want to tell the system, okay, now we want to initialize the list. Now we want to kind of create the list and put some information in there. So we use this new keyword, repeat the data type again. Then in these parentheses, we can either leave them blank, or we can give it a capacity, just like an array. And we can even pass an existing collection into it, for example. So what I could do is do this, and this will create a list based on my array right here. So you can see how it's already starting to be quite powerful. And again, I can prove that also works by running the application, and it's cycling through the numbers that we've passed into it. So you can see it's quite powerful in that respect. But the thing about standard arrays in C#, for example, so let's just work with our standard array right here. If I look at the native methods to do with an array, we can't really do much with it. You know, we have some various methods we can use, like get the length of the array, so the number of items in the array, but not really too much else to do with native methods. So what if we want to sort this information? You know, maybe put the smallest number at the start and then the biggest one at the end. How do we reverse the order of these numbers? You know, various things like that. Well, this is one of the many benefits of using lists in C#. So what we can do, let's look at a few examples of working with lists. So here I'm defining a new list. I can define a new list and just leave it empty. And then later on in the application, when we figure out what we want to actually put into our list, we can dynamically on the fly add items to it. So I could add this number right here, and then another one. Maybe if we want to build an application where we collect numbers from a user, we can kind of, define the list, and then later on we can add in the user's numbers. So when we run the software now, we can see that the list now contains those two numbers that we've added to it using the add method here. But not only can we add things, we can remove things as well. We can do various things natively. But one of the more powerful ones, we can actually sort the data. We can sort it in order. We can even reverse the numbers, for example. So let's define a list with these numbers right here. And we'll use the sort method. And what this will do, this will take all of the integers and sort them in order. And that is the only thing you need to do in order to do that. So if we run the software now, you can see all of our numbers are in sequential order. And that's very easy to do, only just this very short one-line piece of code here. So you can do various things with the list class, and it offers a more powerful way of working with your data. That's not to say necessarily arrays are useless. You can accomplish these things with arrays using extensions like link and things like that, but I won't get into that now. I don't want to complicate this tutorial too much. But I'm just presenting some of the advantages of using lists when programming in C#. So to summarize, if you have a collection of data, whether it's integers, strings, or another data type, and you don't necessarily know the capacity perhaps, you might want to add values during the application. Maybe the user needs to add items, or you want to kind of, control the data in a better way, then maybe list is something for you. Maybe it's a data type you want to explore. But it is a powerful data type, and I do recommend you use lists with your adventures in C#.